Okay guys, I'm going to talk to you today about how to develop linear, exponential, and quadratic predictions based on a data set. Sorry, so in your OneNote, you have this example, and this is basically showing you information about skateboarding. It says skateboarding has become a national pastime and a big business. And so we have the revenues from the sale of skateboard hardware and skateboard apparel, and it's being summarized in the table below. And you can see here that we go from 1996 to the year 2001, and it has the skateboarding hardware and apparel revenue in billions of dollars. And it's asking you to come up with three different predictions: a linear prediction, an exponential, and a quadratic. So I'm going to show you two different ways that you can do this. The first way I'm going to show you is with using the TI-84. So you can see that I've already put the data in my TI-84, and I'll just show you real quick how to do that. You go to Stat, and then you hit Edit. And if you do that, you can see that it gives you a bunch of different lists. I'm going to put all my data in List 1 and List 2. List 1, I put in the years, 96, 97, 98, 99, and so on. And List 2, I put in the money. Now, if I want to come up with a prediction, I'm going to go back, second quit, get out of there, go back to Stat. This time go over to Calculate. And the first one I want to do is I want to do a linear regression for the revenue. So I'm going to go down to number 4, press enter. Make sure that you put in the proper variables. So my X value list was my year, so it should say list 1. So I'm going to do second list 1. And my Y list is list 2, which is good. And then I want to calculate. And so then what I would write down on a piece of paper, I would write down my equation. So my equation would be Y equals, the A value is 0.24, so 0.24x, and the B value is minus 478.65. And that has an R squared value of 0.944. So that's a pretty good R value. Next up, I'm going to do the same thing for quadratics. I'm sorry, exponential is next. We'll do exponential next. So I'll go back to Stat, go over to Calculate, and I'm going to scroll down. I have to scroll down until I see exponential regression, letter 0, number 0. And again, make sure your X list and your Y list, list 1 and list 2. And then we can go down and we can do calculate. Got an overflow error. Now this happened because an exponential equation, it really does not like 1996, 1997, 1998. That's too big of a number. So I'm going to fix that. I should have done that in the first place. So if I go to Stat, well, first let me quit out of here. Stat, Edit. Instead of 96, 97, I'm just going to do 96, 97. And you could even make this easier if, let's just say, let's let year 1996 be year 0. 97 would be year 1. 98 would be year 2. 99 would be year 3, year 4, year 5, and so on. So now I can quit out of there. So I'm going to need to go back. That's going to change my linear regression that I just wrote down. So I'm going to go back and I'm going to do my linear regression one more time for list 1, list 2, and calculate. And it changed the B value. Notice it didn't change the A value at all. It only changed the B value. So then on my paper, I'm going to write down Y equals 0.24x plus 0.386 repeating. And notice the R squared value is still 0.944. So now I'm ready to try my exponential again. So I go Stat, Calculate, and I scroll down to Exponential Regression, List 1, List 2, and Calculate. And so there's your equation for your exponential. So I'm going to write on my paper Y equals 0.487, let's do one more, 0.4872 times 1.2793 raised to the x. And it has an R squared value of 0.991. So that's an even better r squared value. And then finally, the last one is the quadratic prediction. So stat, go to calculate, and go down to quadratic, number 5. List 1, list 2. And notice that with this one, I have y equals, a is 0.04, so 0.04x squared plus 0.04x plus 0.52, and this has an r squared of 1, which means it is a perfect relationship. So based on all of that then, if I wanted to fill in this chart, I would start plugging in the linear predictions based on the different models. So I have my 3 equations that I've written down off to the side, and I would plug in, so remember that I changed my value, so I'm not going to plug in 1996, I would plug in year 0, year 1, year 2, year 3, year 4, and year 5. And I would go back and I would plug those in to each of my equations for x. These are your x values. So in the linear equation, I'd plug in 0 and I would get 0.24 times 0 plus 0.386. So 0.386. And then I would plug in 1 into that equation and I would get 0.24 times 1 plus 0.386, which would be 0.626. And so on. And I do the same thing for the different ones to get your predictions. If we wanted to predict the year for this year, so 2020, well, 2001, so this is 19 years later, so we would plug in x equals 24, and we could plug in and see what the equation would be. So if I were to do this with a linear model, I would do 0.24 times 24 years plus 0.386, and I would get 6 for linear prediction, $6.146 billion. For exponential, I would do 0.4872 times 1.2793 raised to the 24. And wow, that gives me $179.91 billion. And for quadratic, I would do 0.04 times 24 squared plus 0.04 times 24 plus 0.52, and I would get $24.52 billion. So which one am I going to use? I'd probably use the quadratic. It had the perfect r squared value, which tells me that it's the best fit. Now, I also wanted to show you how to do this using Desmos. So if I go into my Desmos, this is just the regular old Desmos calculator. I'm going to go up to the top and I'm going to do plus, and I'm going to add a table. And I'm going to put in the same numbers that I had a minute ago. So 1996 is year 0, year 1, year 2, year 3, year 4, year 5. And now I have to go back to my chart and remember the numbers, 0.52 and 0.76 and 0.6. So 0.52, 0.6, 0.76. And then 1, 132, and 172. 1.32, and 1.72. All right, so I have this, you can see it has the scatter plot drawn for you. Now, if I want to do a linear, the one distinction between Desmos is it does expect you to know the equation. So for a linear model, it would be y1, and you're going to use the little tilde, which is above the tab symbol next to the 1. And then it would be a x1 plus b. And notice that it gives you the same values that I got before. Notice down here I have the a value and I have the b value and the same r squared value. Okay, if I wanted an exponential, I would do y1, little tilde, a, b raised to the x1. And now I can see, here's my exponential. And again, it gives me the same values that I got a minute ago. And then finally, if I want the exponential, y1 tilde a x1 squared plus bx1 plus c. And here is those same values again. And then you can see which one makes the most distinction. If I turn off these graphs, you can see that the quadratic is a perfect relationship, whereas the exponential is closer and the linear is not as close. Okay, so that's the way that you can do these in these two different things. So what I'd like for you to do next, I'd like for you to try on your own to see if you can do the same thing with the Chipotle data. Now be careful with the Chipotle data. If you're going to put in the year, if 1993 is year 0, that means 2002 would be year 9, 2004 would be year 11, year 13, year 15, 17, and then 7 years later, that's year 24. All right, so give it a try, and then tomorrow we will talk about it and make sure that you've got it. That's it. All right, good luck, guys.